This question is titled, Surely there's no object orientation, so what the heck is inheritance in SQL? Let's take a look. Let's say I want to create two tables, A and B, and the tables look very similar. They have columns XY and XY and Z. And I am very much unwilling to type the same thing twice. Maybe I'm a data scientist, and this is why I import pandas as PD, because I couldn't bother to write more than 2 letters and maybe a period anytime I need something from my library. I couldn't bother to import things ahead of time. I want to minimize my typing. And I might say, what could I do about this? How could I make this a little bit shorter? Well, if it's the case that this is an intentional repetition, that it's not the case that these two tables share the same columns just because, but these tables share the column because they have a relationship, I could use table inheritance. I could say table B is related to table A. In other words, table B is all of the columns of table A plus an extra column. That doesn't mean that it's the same data. Because if I insert data into table A and I take a look at what's in table A, it's the original data from table A. If I look what's in table B, it's the original data that's in table B. This doesn't affect the data. It only allows me to specify that one table's layout is based on another table's layout. Because if I wanted to get all the data from both the tables, well, I have that mechanism. That exists. That's just a union. Although, unfortunately, I cannot select star from these and have it automatically figure out what the intersection of the columns are. I wish you could, but you can't. And whenever you're doing this union, you have to have the same number of columns and the same type of columns. So I do have to manually specify, give me column X and Y from A and column X and Y from B. This is what table inheritance is all about. An interesting thing is, in table inheritance, you can actually inherit from multiple tables. So if we have tables A and B with columns X, Y, and Z, and table C that has column W, we can create a table that has all the columns from A, all the columns from B, and any additional columns that are specified. We can inherit from 2 tables. And if there is overlap in the table names, you can see we get a message here saying user-defined column moved to the position of the inherited column. You can see that it doesn't create a duplicate in our result. It just kind of elides that. So there we go. We even have multiple table inheritance. But this wouldn't be useful if it were just the case that all it's doing is just saying, oh, when you create this table, just copy what you had over here, and then you're done. It's not just useful as eliminating some typing. It's useful because changes to one of the tables will cascade to the other table. When we set up this inheritance relationship, what will happen is if we change table A and table B inherits from table A change to table A will cascade to table B. If we add a column to table A, it cascades to table B. And so we see that there is some value, some runtime live value for this inheritance, the ability to set up multiple tables where one change to one cascades to the next one, just like inheritance works in your standard object-oriented programming languages. You add something to the base class, and it is automatically available in all of the subclasses. This leads to an interesting side question that I'd like to discuss very briefly. We have seen that SQL is kind of similar to the programming languages that we've seen, and we've seen in Postgres specifically, there are features that are within spitting distance of some of the features that we've seen in our regular programming languages. It's just that where in programming languages we have functions and variables, in Postgres we have a bunch of other things that kind of overlap in weird ways with our functions and our variables. I want to share with you one of the major differences between programming languages and SQL and the SQL thinking. And one of the major differences is what is considered static and what is considered dynamic. Because all this time we've been talking about the SQL, but in truth, there are actually multiple sub-languages under the SQL. There is the DDL, the definition language, and the DML, the manipulation language. And at one point in time, as I learned it, there was actually the DML, the DDL, and the SQL. And these were 3 things, but oftentimes people say, oh, SQL is the highest level and DML and DDL are the other 2 levels. DDL being anything that defines how the data looks, create and alter. The DML being anything that updates the table. Where the select shows up, oftentimes people say it shows up in the manipulation language. In my view, this is the select by itself and nothing else, and these are the DML and DDL, but that's a very minor difference. What we have discovered is that in SQL, some things can be made dynamic and other things can't. we cannot parameterize in a select statement over the columns. Otherwise, that would have made the code that we wanted to write earlier much easier. We cannot parameterize over the table. We have to do a union and then add in that information. We can parameterize over a filter that we're applying to this. We can parameterize over the value that we're using for C, but that's about it. Now, the existence of functions in SQL do allow us to break these certain assumptions, but we do pay a penalty for them. Because if it were the case that we genuinely wanted to do a selection from A and B, where we figure out what the intersection of these two tables are in terms of the columns that they have, and select those, we cannot parameterize on that in raw SQL. But maybe we could use the information schema that is available within, let's comment this out here, the information schema that is available, and by the way, this is gets really tricky. We could use the information schema that's available in Postgres to ask what columns does B have, and we could ask the information schema what columns does A have intersected with what columns does B have, and we would just have to figure out how to coerce these two values into a query. And we might try to write a function in PLPG-SQL. And in this function, we might end up doing many contortions. Let's do one more thing. This is our result. And we're going to see that this thing doesn't actually work the way we do, but what we might do is we take all the tables, we might select the columns, we might then intersect those columns to find out what's in common. We might then construct via string concatenation a query that selects these. We might even try to wrap each of the outputs of those queries in a row so we can return a single type of record. But unfortunately, this won't quite work. And the reason this won't quite work is SQL functions require that you specify what the output is, either in the header here or in the calling syntax here. And somewhere we have to specify we expect an X and a Y. We're stuck. We can try and get around this by turning these into strings or turning these into JSON values and try and escape this value in that fashion. But fundamentally, there are limitations, and the limitations are down to certain things in SQL are considered static, certain things in SQL are considered dynamic. What is considered dynamic is the data within the tables themselves. What is considered static, which tends to be enormous contortions and very difficult to get around, and even though this comes almost close to what you want to do, it can't make it to the finish line. It's because the underlying structure of the table itself is considered static. But it's not considered fully static, it's considered semi-static. So you've heard people can do migrations. They can alter tables. They can add columns, remove columns, add indices, remove indices, add constraints, and remove constraints. Here is my view of all of this. I think table inheritance is kind of cool. But I think the use case where you alter the table later and you see it update on the other table is actually fairly limited. Because it is my view that if you are altering the structure of your tables, you had a modeling problem. The alter statement in SQL is not something that I think you should be doing just because, oh, we have a new field. I think that means you've modeled the data incorrectly. Because we can clearly see that SQL does not consider the tables to be a static entity that you can parameterize over. Which means even though the DDL does give you the ability to perform alterations, it makes it very clumsy, but you cannot make them bitemporal. You can never rewind to a previous table state, and you fundamentally have difficulties parameterizing over these. I think any time that you find that you're designing a database, and in that database layout, you anticipate constantly performing migrations or updates to the structure of those tables, it is likely that you have incorrectly modeled your data. The structure should be data, not structure, because structure is fundamentally a static entity, and we can use Python 3U in order to try and get around this. And we can squirrel away things in JSON types and whatnot in order to try and get around these limitations, but we will be contorting ourselves against the underlying concept of SQL, which says there is a firm difference between data, which is dynamic, and structure, which is static. And Python says everything can be dynamic, including structure, but SQL makes a firmer choice here, and this is deeply baked into the language. With that said, maybe we're tired of SQL, And maybe we say, you know what, Python makes my life so much easier because it allows everything to be dynamic. And so, if we were tired of writing SQL, what might we do? We might decide, how much can we really do in Python? And this question is titled, if I'm tired of writing SQL, can I put Python in my stored procedures? I think we've seen some examples that already look like this. If we have some table, we can create some function that performs some operation on this table, and this function can execute any arbitrary SQL, and it can construct this SQL via string manipulation, which means as long as we can figure out how to get this return type to be the thing that we want, we can perform any arbitrary SQL. And one way we can hide some data to bring it out is we can store this as JSON-B and then unnest it on the other side. We do all sorts of contortions to get around this. Largely, here's what I want to share with you. Python is a very useful tool to use strategically within your database. The U here at the end of your PL Python 3U is because your Python 3 extension is unsafe. Your Python 3 extension can access files, it can change system state, it runs as the same user as the database. And in fact, what you might even see is every time you start a transaction, a Python interpreter is started with a different PID. So there are some serious considerations when you decide to try and stuff Python into your database. You cannot just assume that things are safe in the same way that they would be if you're writing SQL. However, where this can be useful is there may be cases where you may want to have one source of code which doesn't interact with the outside world, which doesn't really take untrusted user input and do anything with it, where you don't have to worry about that safety issue, and you only want to write one version of it. You don't want to write a Python version of this analysis or a Python version of this algorithm and an SQL version of this algorithm, and maybe the algorithm is fast enough in Python, or maybe it's something that's going to be slow anyway, like it's a NumPy operation, and you want to write it once, and you want to implement it, and you want to share it in both cases. I think that's a good use of Python. Constructing an ORM on the SQL side, using PL Python 3U and the pickle module, I think is a fantastic idea if you want your coworkers to be afraid of you. If you want them to say, I don't want to work with this person, they do some very strange things. I think it's a provocative idea, and it might be an interesting idea to maybe see how far it goes, but I'm not really sure that it's a good idea for us, for our general health and well-being. Where I see Python working together with SQL is not deeply embedded in the tool. It's possible to pretty much do anything you want in Python in a function here. And there may be cases where it's easier to just make use of some existing Python code. And it may be cases where you want to have validation or constraints on both sides but only write them once. That's absolutely a good use of Python. But largely, when I write SQL, I am thinking about how do I leave everything else behind. When I write SQL, I should be thinking about how do I write SQL like SQL wants to be written. I should be thinking, if I'm writing SQL, how do I make sure that I keep all of my logic in SQL where it'll be efficient, it'll be secure, it'll obey all of the security restrictions, row level restrictions, column level restrictions, table level restrictions that I have on my database, where it doesn't force me to go into contortions to try to do something I'm not supposed to do. If SQL by itself is not enough, maybe I'll reach for PGSQL, which is basically SQL with a little bit of procedural wrapping, but only if that's not enough will I reach for PL Python 3U, because I don't want to be the person who is trying to make everything look like the one tool they know, because while it will work in the short term, it will not work in the long term. You're going to have a bad time.